Hello, Mr. Hamid and Mr. Kiran.
Hello, good afternoon, Mr. Dwi.
Good afternoon,
Thank
Mr. Hamid and Mr. Kiran. So we will
Yeah,
start.
good afternoon. Good afternoon, Dwi.
Good afternoon, Mr. Kiran. How are you?
Am I audible to you all?
Yeah. So we will start the webinar now.
Yes.
Are you ready, all of you?
Yes.
Yeah. So we can start webinar. I will present first in bahasa and I will over to you, guys. Thank you.
Yeah. Thank you.
Baik, mari kita mulai saja webinarnya. Saya ucapkan sekali lagi selamat datang dan terima kasih kepada bapak-bapak dan ibu-ibu yang sudah meluangkan waktunya untuk bergabung di webinar kami kali ini, yaitu Asia Pacific Webinar Series. Pada webinar ini kita akan berbicara mengenai Visi software ya untuk molding design. Sebelumnya perkenalkan kami dari Asia Pacific selaku autores dari software Visi CAD CAM. Di sini ada saya selaku host Dwi Darsono dan co-host saya ada Pak Bambang di sana. Halo Pak Bambang.
Selamat siang teman-teman.
Selamat siang juga.
Dengan Bambang Nugroho dari Asia Pasifik Indonesia.
Baik, apa kabar Pak Bambang?
Alhamdulillah baik Mas Dwi. Mas Dwi apa kabar? Lama tak berjumpa nih Mas Dwi.
Ya, sama juga Pak. Baik, alhamdulillah.
Oke.
Okay, hello Amit and Kiran. So we are welcoming you and today Mr. Amit and Mr. Kiran as our speaker for today's topic. So welcome Mr. Kiran and Mr. Amit to our webinar.
Thank you so
Terima
much.
kasih.
Terima kasih. Oke. Mungkin kalau sebelumnya rekan-rekan ya, bapak-bapak dan ibu-ibu bertemu dengan Asia Pacific, kita sering mengadakan seminar ya, namun karena memang kondisinya tidak memungkinkan agar kita juga tetap terhubung dan update informasi untuk bapak-bapak dan ibu-ibu, maka kita menyelenggarakan webinar. Harapannya nanti ketika bapak-bapak dan ibu-ibu sudah full bekerja normal di perusahaan, bisa menggunakan teknologi dari Asia Pacific ya, dari software yang kami bawa. Oke, langsung saja mari kita mulai. Perkenalkan dulu ya, kami dari Asia Pacific selaku distributor, regional distributor yang ada di 5 negara, yaitu Malaysia, Singapura, Indonesia, Thailand, dan Australia. Di Indonesia sendiri kami mendistribusikan beberapa produk yang mungkin akan saya jelaskan sedikit. Di sini kami mendistribusikan salah satunya software SketchUp ya, mungkin bapak-bapak dan ibu-ibu juga mengenal ya software ini. Software ini software 3D design juga, cuman memang banyak digunakan untuk konseptual design. Dari namanya aja udah jelas ya, sketch. Jadi sangat mudah untuk membuat 3D design di SketchUp. Banyak sekali SketchUp ini digunakan oleh rekan-rekan arsitek. Tapi memang sampai saat ini pun pengguna SketchUp sekarang bukan hanya arsitek, termasuk rekan-rekan di kalangan manufaktur juga menggunakan software ini. Kita juga distributor dari software Vire, salah satu produk yang ada di Chaos Group. Selain itu kita juga distributor untuk produk PTC Creo. Mungkin bapak-bapak dan ibu-ibu pernah mendengar nama Pro Engineer yang sekarang sudah berganti nama menjadi Creo. Kita adalah distributornya di Indonesia. Kita juga distributor untuk software DWG alternatif, yaitu ZWCAD dan BricsCAD. Software DWG ini license-nya permanen, dia ringan dan juga cukup powerful untuk menggantikan CAD software yang sekarang mungkin bapak-bapak gunakan dengan sistem subscription. Jadi kalau bapak mungkin berminat untuk menggunakan software DWG yang license-nya permanen, kami siap untuk mensupport hal tersebut. Dan tentunya kami juga adalah distributor untuk produk Hexagon. Salah satu produk Hexagon ini adalah yang hari ini kita sedang bicarakan, yaitu software Visi CAD CAM. Selanjutnya kita juga distributor untuk software Archicad. Ini adalah software BIM atau Building Information Modeling. Ini software 3D design untuk bangunan juga, tapi basis teknologinya adalah BIM atau Building Information Modeling. Kita juga distributor dari produk hardware Leica. Leica ini adalah laser scanner ya untuk mendapatkan objek 3D dari keadaan di sekitar kita ya. Nanti di scan, kalau kita mungkin mengenal scanner 2 dimensi, ini objek 3D yang kita scan menggunakan 3D scanner Leica. Kita juga distributor dari produk Epson, ada plotter, ada printer, ada proyektor, ada printer label, dan seterusnya. Ini produk ini mungkin sangat akrab ya, karena kita juga pakai sehari-hari. Biasanya di office banyak tuh tipe L ya. Dan kita juga tentunya adalah distributor dari 3D printer industrial grade, yaitu Rise 3D. Ini adalah 3D printer yang memiliki build volume atau build size 300 kali 300 kali 600. Jadi buat bapak-bapak dan ibu-ibu yang butuh 2D printer atau 3D printer, kita Asia Pasifik bisa bantu support produk tersebut. Oke, jadi saya juga akan menginformasikan ulang ya. Selama webinar ini, bapak-bapak dan ibu-ibu bisa bertanya di kolom Q&A. Nanti di akhir sesi, kita akan menjawab pertanyaan-pertanyaan dari bapak-bapak dan ibu-ibu, dan 2 pertanyaan terpilih. Nanti kita akan berikan hadiah voucher masing-masing senilai Rp100.000 ya. Setiap peserta silakan kalau mau bertanya lebih dari 1 pertanyaan, silakan. Mungkin juga karena memang case-case sering dihadapi bapak-bapak dan ibu-ibu di tempat kerjanya, silakan Pak, tolong taruh aja sebanyak-banyaknya pertanyaan di kolom Q&A. Nanti kita akan seleksi ya. Tolong jangan taruh di kolom chatting karena kita akan sulit memfilter pertanyaannya. Tolong ditaruh di kolom Q&A. Oke, sebelum kita memulai pertanyaannya, saya ingin melaunching polling. Jadi mohon dibantu untuk mengisi polling yang kita buat. Dan pollingnya akan launch dalam hitungan ketiga. 1, 2, dan 3. Ya, silakan dibantu untuk mengisi polling yang kami berikan. Polling ini akan berjalan dalam waktu 1 menit ya. Oke, polling akan ditutup dalam waktu 10 detik lagi. Mohon dibantu untuk bapak-bapak dan ibu-ibu yang sudah melihat pollingnya untuk diisi. Oke, kita berikan waktu 5 detik lagi. Kita akan akhiri polling kita dalam hitungan 5, 4, 3, 2, dan 1. Terima kasih kepada bapak-bapak dan ibu-ibu yang sudah membantu kami untuk mengisi pollingnya. Dan kita akan langsung saja masuk ke inti dari webinar kita kali ini, yaitu visi untuk mold design. So, Mr. Amit and Mr. Kiran, I will introduce all of you guys to our speaker, Mr. Amit and Mr. Kiran from Hexagon. They will talk about visi for mold design. So, Mr. Amit and Mr. Kiran. Hello?
Yes, 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 Mr. Dri.
Offer it to you ya.
Yes, yes. Thank you, Mr. Dri.
Hello everyone, my name is Kiran Devraj. I work as Senior Technical Manager for Hexagon Production Software. This is the agenda for today's session. I'll be briefing you about overview of Hexagon Production Software, Visi overview, and deep dive into Visi mold, and then at the end let's have a Q&A chat. Headquarter of production software is in UK, having in direct offices across the globe to list Italy, France, Germany, Netherlands, USA, India, Spain, Japan, South Korea, China, Vietnam, and Thailand. We have a development teams in UK, USA, Italy, France, Germany, India, and Russia as well. We have operating through resellers across 45 countries, and also we have direct employees over 800 plus. With a revenue of 140 million euros, we are #1 CAM provider. As per industrial seats installed, excluding the educational version, production software is in leading position as per SIM data. It is a demanding task to maintain and refine the spectrum of solutions, but it gives our company a stability and ensures that we can address a large market on the whole. Now let's see some of the product lines from Hexagon Production Software. HCAM is a leading CAM system for NC part programming with unparalleled ease of use and sophisticated toolpath generation. It's the only CAM system you will need for milling, turning, and mill turn machining. WorkNC CAM software is the premier automatic CNC software for surface or solid models in mold, die, and tooling businesses for 2 to 5 axis CNC programming. WorkNC is used by all Western, Japanese, and Korean automotive makers and well-known OEMs from a range of other industries. Cabinet Vision is a software for woodworking professionals. It includes design, rendering, pricing, bidding, and cut list report capabilities. Redan is the total CAD CAM solution for cutting sheet metal. We understand the metal is precious in your business, and with our software, your company can significantly reduce inventory and increase material utilization, allowing you to realize the true return on your investment. Visi is a complete CAD CAM solution for tool makers, right from design to manufacturing. It offers a great tools to reduce design cycle time and ensure productivity. Alpha CAM is another intelligent CAD CAM software for woodworking, metal, and stone cutting operations. SurfCam is a market-leading computer-aided manufacturing system for NC part programming. WorkPlan software solutions was developed to meet the requirements and replicate the specific procedures and codes of the CAD CAM industries. Budget, time, manpower, materials, resources, costs, and cash flow. WorkPlan will help you control your manufacturing progress and increase your productivity. Smart is the leading supplier to the whole world of powerful viewing software designed specifically for stamping die industries. WorkExplore is a powerful CAD collaborative viewer which can be used by various departments across the organization. WorkNC Dental is a dedicated CAD CAM software for milling complex dental processes. Fasis is a tooling and resource management software from Hexagon Production Software Unit. These are all the list of our major global customers across the different industry vertical, right from automotive, aerospace, electronics, medical, and machinery. So let us deep dive into today's topic, that is Visi. Visi is an industry-specific CAD CAM solution for tool makers. Right from design to manufacturing, we have all the different modules in Visi which is going to be helpful for your design activity and also going to be beneficial for the organization. So we can perform injection mold tooling, pressure die cast tooling, transfer dies, press tooling, sandcast tooling, vacuum forming, etc. So in Visi Mold, we have different file formats supported, right from CATIA, DWG, Inventor, Parasolid, ProE, SolidWorks, STEP, STL, Unigraphics, and Point Cloud Data. So these are all the major file formats which are supported inside Visi. But at the same time, you might receive an IGS or step file or any neutral file formats from your customer. Then working on those component is time-consuming process because you need to get into details of fixing the geometrical errors. but inside Visi, how this can be done so easily with less time, let's look into that. I have taken a small example here where I'll be working with an IGS file and converting into a clean solid geometry. Hello, so welcome for the demonstration, and let me start by importing an IGS file. So I import an IGS file with the default options. Here you can see the progress bar, which indicates what is the status of the import body. So this is the file which I have received, and I need to develop a mold or even a core cavity extraction for the same component. Before that, I would like to check for the validity of the body. So here we have a search command where I can just search for a command or a particular option. So the moment I pick up the command, I just follow the instruction space. This is helpful if you are a fresher or a new user. So let me select the whole body. The body seems to be okay. That means it doesn't have any self-intersecting contour or overlapping surfaces as such. The next option would be, let me check for the number of sheets or surface it has got. It has 0 solid and 1 sheet. So I need to convert the given sheet into a clean solid geometry. So how do I do that? So let me perform, just hover the mouse. You can see that all the open edges are highlighted. So irrespective of the size or even a very minute opening edges are listed. You can see that it is very much visible. So with this option, it is quite easy for any user to identify where are the opening edges are available. The next thing would be, I need to fix this one. So let me activate the automatic trimming option so that the surface will get trimmed on the necessary area itself. In the similar line, I would like to create a patch surface in order to fill these two contours. So let me do that. Have a look how easily and the surface is going to patch with by maintaining a proper tangency with respect to the existing surface around. Similarly, I would like to create one more surface here. So that's how. Let me unite this. Let me check once again. Yes, you see, I have got 1 clean solid and 0 sheet. So in this way, we have converted a given IGS into a clean solid geometry having no faulty faces or geometrical errors. So once you have a clean solid geometry, we have an option to compare with the given original data in order to see the similarities and the changes between the similar component. And also you're going to see in the next demonstration how do we perform draft analysis and check what are the faces which is not drafted. Plus we will also demonstrate how we can create a parting line, parting surface and core cavity extraction. So once if we have converted into a proper clean solid geometry, the next option would be I need to check for the draft analysis, because I'm not sure whether the given component is completely drafted or not before we proceed with core cavity extraction. So let me perform the draft analysis. This is the part, and then I would like to change the color graphics as per my requirement. You can customize the same. You see that this gives you a nice color code which indicates the undercut and the core cavity split surfaces. So that's how it is very much useful in order to before getting into the core cavity split, it is equally important for us to know where exactly the software identifies for parting line. Going forward, I would like to even check for is there any opening, or is there any draft faces or not. So hope you can see that the green color indicates these are all the non-drafted faces. The gray one indicates it is drafted. The same can also be checked with Surface Analyzer. Have a look. You see the draft angle is 0, and here it is drafted with -10 degree. So all the one which is colored faces are non-drafted, and the one in gray color are drafted. So if you want to go ahead with this, I would like to imprint the color code so that it is easy for me to apply a draft and then check it accordingly. So let me apply a draft now. I would like to apply a draft onto this face. If you see that I have beautiful option to make use of it, because it's already blend is available, so I need to apply the draft angle, and automatically the blend is recreated every time. So this is how the draft can be applied. So let me apply a draft over here. Visi comes with a very powerful selection method. How exactly? Have a look. I would like to select from this region to this, and this is the face to be drafted. So without much clicks and picks, I have selected the entire range in just a 2 click of a button. In a way, Visi is very powerful in selecting the surface, required surface or a geometry. So let me apply a draft there, and then I will just have a draft analysis once again on the same component. So let me update this. Yes, can you see that this face, which was colored one like this before, is now turned to gray one even over here. So this indicates that we have applied a draft, and that's the color graphics is also updated. So going forward, I have already completed the entire draft over here. So let me open that. So this is the model which is completely drafted, and you can have a check with respect to the data shared by the customer. So what do I do now? Let me have a comparison between these two. So I use a compare, and these are the two parts to be compared. So let me pick the one and also select another one. Just go for a comparison. You see that the pink color region indicates the common face, indicates that the two different faces from the two components. So if you would like to untick it, so you see this is what the exact changes, or what are the internal and external differences that you got. If I want to show only the external to internal, you can also take this option and then have a look. Yeah, this is what the exact change, indicating the internal and external diameter. If you want to have a change, you see this is pertaining to component 1, this is with respect to second part. So that's how the comparison tool is very much effective in order to compare the two similar model. So what we have done so far, we have analyzed the given IGS, converted into a clean solid geometry, checked for the draft faces. Wherever the faces are not drafted, we have applied a draft, and then we also compared with respect to the original data supplied by the customer. Now the next option would be, I would like to create a co-cavity split for the given part. How do I do that? Let me make use of the automatic option by splitting this part. So let me select the given part, and then rest will be taken care by the software in order to split it automatically. Have a look. So this is how the given part is split across, having the core and cavity side along with an undercut and the side cores. Suppose if you do not wish to go with the software recommendation, you can just quit that and then create your own as well. So let me create a parting line by my own. So I would like to create the parting line on my own. So here I would like to, this is the part which I need to go for it. Have a look. Easily we have created a parting line. If you would like, if you're okay with this, you see a core cavity is properly extracted. So now let me apply this and then draw a split line. So once if you apply the parting line, the next option would be creating a parting surfaces. So let me do that. I just make use of dynamic split plane option here. Change the shading mode. Ensure that we have multiple methods of creating parting surfaces. I use the one which is relevant at this time, and then I would like to pick this edge up to over here. I would like to create a parting surface. Yes. Similarly onto the other side, from here hope you're observing that I'm just not select each and every edges manually. So you see, now let me use some other option. Probably this time I would like to create a tangent patch from here to here. Have a look how easily, and we have created a very smooth surfaces connecting the other two surfaces. On a similar line, I would like to create and complete the parting surface creation along with the peripheral edges. There you go. Okay, so that's how the parting surface is created for the set across, and I have many more to do that. For example, these are all the parting lines which I need to say fill hole with a patch. Let me update it. You see, in a one single click all the holes have been patched properly. Suppose if you are using one or the other CAD currently, you can also import the any geometry created in some other CAD file. So let me do that. I would like to import this body over here. Okay, so let me apply for this. So now I would like to import, say, merge this, and I'm just importing a sheet which is created in some other CAD file, but as Visi supports different file formats, I'm just importing a step file, and let me merge it like this. I'll go back to my parting surface, change the shading mode, import the sheet body, and yeah, so this is the sheet body imported, where it is automatically going to create or consider that as a parting surface. If everything is fine, you just have a check. You see how we have created a core cavity extraction from this. So let me decide the thickness of a mold and say create mold. Yes, so we are done with the first phase, that we have created a core cavity insert from the given part. So let me show it to you once. So this is the part file which I've got, and over to it. So this is how we have created the parting line, parting surface, and the core cavity extraction. So in the next demonstration, you will be visualizing how we can build an entire mold tool on the core cavity plates created. In addition, you will also see how do we make use of standard elements and also user-defined elements in our mold design. Plus, we will also show you how we can create a slider core and a lifter mechanisms for the mold design. So after creating a core cavity split, I would like to build a mold tool for the same, where I just make use of a tool design option. The software is going to load with the default, but then let me pick the insert plates. So I would like to define with respect to the given origin. You can see that automatically the entire mold tool has been updated. So here you can also select the standard as per your requirement. We have DME, Futaba, Hasco, Musburger, Pedrotti, Strike, etc. And suppose in this case, if I want to choose Hasco, and I have got various configurations over here, let me select the one as per my requirement. Once the mold base is built, you have more flexibility in order to decide what are the plates you have to customize for. In this example, suppose if you think this is not relevant to my design, you can just say delete it. You can also do the same thing onto the bottom one. Suppose if you wish to change some of the dimensions, you can just go and pick up the plate and you have the different options here to select for. Similarly, if you want to change some of the items here, you can just change accordingly the way you require. So similarly, if I want to change, say let me give an opening value about 2 over here, and then ejection side opening value about 2 again. So that is how the complete mold base can be configured and customized as per your requirement. Going forward, you can also add the preliminary standard templates with respect to the Hasco which I've selected. So let me load the Hasco one, and this is the normal layout which I'm going to make use of it. So automatically the software consider the standard elements with respect to the configuration selected. So here you have an option to even select or deselect as per your design intent. For example, if you think so that this locating ring is not required, you can just untick to delete it. Similar way, I don't want it to be on the bottom side as well. Let me untick this. So with the remaining options, I would like to go with the default and then just say accept this tool base. So once the tool base is accepted, you're going to have the complete mold base created for your part. Now let us move forward by creating some cavity inserts and then using some standard elements. So with this, I would like to go for insert cavity management and choose the plates accordingly. So I have got the inserts to be selected, and I need to pick up the injection plate. So here the instruction space is telling me what exactly I have to pick now. So then I'm going to select an injection plate, and that's how the cavity has been created on these two plates. If you want, you can choose between the cylindrical type, or even you can go for the drafted one. Hope the preview is clearly telling us what exactly the type of insert cavities we have creating. So let me accept that. So once the cavity has been created, I'm going to make use of some of the standard elements. Let me show you what are the standard mold catalogs are available within us. You see, we have these many suppliers available in our library, and out of which these are all frequently used. That's how we have been customized and kept it in the standard element list. Now I would like to insert some of the mold standard elements. Say let me use Hasco, and then I'm going to make use of a sprue bush. Say about I have got different parts here. Let me choose Z511R. So here it is clearly stating that what are the plates to be selected. So this is my start plate and this is my end plate. I would like to go with the default setting, and you have the different configuration items to be selected for. Let me use the default one and then say accept it. That's how the sprue bush is created here. Now there are a few parts which are customized, and I need to use it in the existing design. So there are a few non-standard parts where I can bring in and then consider it as an element or a standard one. So how do we do that? So let me use some of the user-defined elements. I would like to load the user elements here. So I'm gonna pick the user element. So I've got this register ring which is defined or created by the user. So here I have an option to place it accordingly, and then if you want you can add an instance or confirm this. So once if you have placed, let me go to a solid group manager and then dissolve this, so that it is going to behave as a normal part. So that's how we can also bring in the user defined elements into the mold base. Let us switch back to standard elements, and this time I'm gonna use the fixing. So I'm gonna select the start plate and the end plate. Let me define by selecting over here with, say, the diameter I'm gonna consider 8. Okay, confirm this. And now I shall mirror it. The best option of mirroring here is we can mirror it about so this is the element to be mirrored across these points and all together. You see? So in a one mirror command I have created a mirror about two directions. One is X and one is along Y axis. So until now we have seen how to add a cavity inserts and then use some of the standard elements along with user defined elements as well. Next, let us see how do we define lifters and slide cores. So now let us define a runner gate and also a cooling channel. Let me turn on only the injection assembly. So here let me say create runner. I have a runner wizard which takes you from circuit, section, parts and also the gate along with an injection cone definition. So you have different types to be selected here. Let me choose the one that is straight for me, and hope you can see the preview over here. So let me go for a section. You can go for a semicircular, triangular one, trapezoidal, circular one as per your requirement. Say let me have a total height of say 10. This is the cone created for injection cone. Let me accept the result. You see, that's how a runner gate is created for this component. Going forward, let us also add the cooling circuit for this. Now let us see how to add a cooling circuit or a cooling channel for this design. If you see that, this is what the existing cooling circuits that I have added for this. Let me show you the one. How do we do that? Now you can add a group for this and then you can sketch the channel required. So this is the plate where I need to go for it, and can select the orientation. If I would like to have the cooling channel from here over to this length, that's how the cooling circuit is added. You can also add fittings over here. Let me choose the one. Confirm this. I would say solidify this cooling channel. Hope you can see that this is what the cooling channel I have added now. Visi has a dedicated module called Visi Flow, where you can perform plastic flow simulation, which comprises of gate location definition, filling stage, holding stage, and shape analysis. We have a wide range of material database to simulate it, plus you can also estimate the warpage and shrinkage simulation. But now in the following demonstration, we are going to see the light version of Visi Flow called Flow Light. If you have a Visimode license, comprehensively you can perform a part level flow analysis. Let us have a look into the same example. Let me use a flow light wizard. I would start by creating a mesh for the given body. Let me choose the default options, or even if you want you can change some of the settings and then accept it. You can see that we have created mesh data. Going forward, I will assign and compute the thickness. So thickness calculation is in progress, and if you want, some deviations are available, and if you want to change that, you can assign a thickness or else proceed further with formatting. Let us give some relevant name for this. It's a flow analysis at part level. So once the given parameters are formatted, you are good to go to define the remaining boundary conditions like injection point, material, etc. So let me assign a material. I go with the default ABS option, and then I would like to pick up the injection point here. So let me pick up one injection point and then another injection point. So once you have selected the two injection points, you can have n number of points picked. So here you can also check for the different configurations. What if the injection point is selected at this location, how the results are going to vary? What if the injection point is changed, and how the relevant result is going to depend upon? So rest all is fine. Let me calculate this flow analysis now. So in the light version of Visi Flow, you can estimate the temperature, pressure distribution across the part at the filling stage, and also you can evaluate air traps and sink marks, well lines. So it is going to compute the well lines created so far. Have a check on this, where the well lines are created. You can also find the air traps. With this, you can also check the overall quality of the part. The one which is saying it is too high, the pink indicates the problematic area, and let me go for the pressure at the same time. Have a check on the overall quality. You see, the pressure distribution across the part is very good. So this is how the quality of the part can be estimated with the help of flow light. Once the complete mold tool is built, you can perform a collision check as well as physical dynamics check by simulating or animating the mechanical movements of the entire assembly in Visi software. Nonetheless, Visi has a very powerful documentation option where you can create a complete set of part drawings and general assembly drawing in much more easier and automatic way. Okay, so far we have seen how do we import IGS file, look for the geometrical errors, fix that, convert into a clean solid geometry, look for the drafted faces. If it is not drafted, apply a draft, create a parting line, create a parting surface, and then create a core cavity extraction. Once the core cavity insets are extracted, we have built a complete mold base for that as per the industry standard, and then we have also used user element and also standard elements. We have also seen how do we add slide core assembly, how do we build on top of it with the help of a lifter or a slide core pen, and then we have also created a runner gate system along with a cooling circuit. So with this, we have come to the final stage of the mold design, that is documentation. So nothing is complete without documenting the entire design whatever we have created so far. So let me go for the documentation. You can see that I will switch to automatic mode and then just say create it. So just use the automatic option, sit back and relax. The rest of creating part drawings, assembly drawing, everything will be done by the software itself. Hope you can see that these many sheets have been created by the software with the peripheral dimensions. If you would like to add apart from this on your own, you can still select it. You can also select your own page, and let me define the mask for this. So now let us define standard views. Even here you can change the scale as per your requirement. You have all the flexibility and freedom to change it. So nothing is complete without adding a part list. Let me use all the rows, and that's how you see the complete assembly drawing is created with the bill of material or a part list table. Visi Electrode offers a complete solution for electrode extraction, stock definition, and managing the entire set of electrodes created, and also documentation is much more easier. Let's have a look into this. Now let us see a demonstration of electrode design and documentation. So in Visi we have a dedicated set of commands under Visi Electrode. So let me extract an electrode. So that is the area where I need to extract it. You can see that the electrode is automatically created. Now let us see one more method of creating an electrode. I can also switch back to the CAD function in order to see another way of extracting the electrode here. Let me move this face a little bit upward. Meanwhile, I would like to create an electrode extraction from this piece of geometry. Let me highlight the one of the interest. You can also evident the CAD capabilities in creating this. Here, since it is difficult to manufacture this type of electrode with the sharp edges, I would like to modify the same. Let me apply some radius. That's how an electrode is extracted. Let me change a bit over here. Now for this electrode extracted, let me define a stock. I just need to pick this up and the body to check for a collision. You see the relevant stock has been added. You can also set the stock type either with circular or rectangular one. You can also mention the width and depth of the stock definition, or there are some standards available where you can pick this up again. You can also change the reference axis from top to bottom or manual or even at the stock bottom face. Let me have from the bottom surface over here, and then for this you can also check for a collision if any. No collision detected. That's perfect. If you want, you can also add a holder library. So I have different standards right from Arrova, System 3R, Hirschman and Musburger. Let me have an Arrova holder library here. Place it accordingly, and that's how the electrode is created. With the erosion data, you have an information on projected area and the burnt area along with the cavity depth. So this is my first electrode created. Similarly, let me show you how we can add a piece of electrode on different region. This time I would like to select this slot. This is the body to check for a collision. And then you can also check for collision here. You see there is a collision detected. If you would like to highlight it and draw a curve on the collision check, you can turn this option on. Can you see this here? It's been highlighted by drawing a curve where there is a collision. Modify this and then apply a blend over here. Now let me extract an electrode once again. To add some strengthening purpose, you can also mention the extrusion along with an angle. Okay. Check for a collision. Perfect. I will show you one more electrode extraction on this region. This is the body to check for a collision. I would accept with the default option, and then let me create a stock for the same. This is the body to check for a collision. Okay, if you want, you can reduce the width and depth of it, plus say confirm this. Now all the electrodes created can be well managed with Electrode Manager option. Here all you have to define the project parameters. Electrode project is the name given, who is the sender, which machine I'm using here, who is the author, you can also mention the same, and this is the workpiece to be picked up. That's the core insert name. If you want, you can also define the material, and I'm going to define a plus feature electrode here. You have a provision to define the finish mode, the spark mode, and the roughness unit value. Typically we go with RA, and let me have 0.8. This is the electrode to be picked for. There it is. Similarly, I can add another group. This time I would say it's a square pocket. And in this one, this is the electrode to be picked for. The electrode has been defined in the EDM manager. Now I can create multiple electrodes by a drag position method. This is the reference point to be picked and placed, one and another one here. Now creating or documenting all these electrodes is much more easier in Visi Electrode. Let me show you that. I go with the list and then just confirm the list over here. You can also define the mask. Let me use portrait type. So here are the list of electrodes created. So this has the electrode list along with the relative tool position and the type of electrode used, the oversize, the material, and the stock definition, when it is created. All the piece of information are available here. A complete report. Let me define it on the desktop. I'm gonna create with a new folder. I would say this is my electrode report. Pick this one once again. So this is how all the piece of information has been added here. You can see that the electrode has been created, and plus you also have the detailed information, the position for 2 electrodes, 3 electrodes created. I have a customer called Crossen Engineering, and here are the initial challenges faced by them. They were looking for a low-cost tooling options, working with multiple CAD files and avoid data loss. Manufacturing defects are found at the initial stage of tooling itself, and they have to avoid the cost inflation further downstream for manufacture. Training cost and high-skilled engineers are very much challenged. So after they use our Visi solution, the initial challenges were no more exist. You can read the testimonial from Mr. Peter Crossen, the business development manager, who says that average tool design time reduction of 40%. And also he says that every mold we make is designed in Visi and manufactured on our range of 3-axis and 5-axis Herco CNC milling machines. So this is the testimonial from Crossen Engineering. So with this note, I would like to conclude that Visi is easy.
Hello. Thank you, Mr. Kiran and Mr. Amit for the presentation. So we already see the presentation about how Visi handle mold design ya. Jadi tadi kita sudah melihat bagaimana ya Visi menghandle mold design, mulai dari kita handle non CAD data ya, CAD data dari luar Visi, lalu kita fix geometrinya, lalu kita buat core cavity-nya, kita buat mold base-nya, lalu kita analisa plastik flow injection-nya. Terus juga kita bikin Electrode Design sampai kita buat dokumentasinya. Oke, sekarang kita akan coba masuk ke sesi question and answer. So, we will go to the question and answer session. We already set several questions to Mr. Kiran to answer. So, I will read the question and maybe Mr. Kiran, you can answer the question, yeah?
Yes, sure, I'll do that.
So the first question maybe I think from Mr. Iwan Musta. He asks about, please simulate flow material through inside the mold. How about the riser design? for reduce the gas and trap insect despite porosity after material filling in finish. Okay, that's the question, Kiran.
Yes, so thank you so much for asking this question. To answer this, whatever in the demonstration I have shown is a light version of flow functionalities. We have a separate module called Visi Flow where you can define or even you can simulate the runner, the gate, along with the cooling circuits, everything. So that what is the effect of having a runner gate system within the mold, you can also simulate that along with the riser. It's available.
Okay, so it's possible. Yeah, maybe Mr.
Yes.
Mr. Iwan, if you want to know more about how Visi handle plastic flow simulation, maybe we can discuss more in your office. Yeah. So we go next, the second question. What the key added value should we highlight from Visi to customer who already have an existing CAD software system so that they consider switching to Visi? That's the question.
Okay, so once again, thank you for asking this question. As I said, if you are using any other CAD system, those are all very in generic mode, whereas Visi is a dedicated CAD CAM solution for tool makers. So the one who is into die mold design or press tool design or injection molding design or pressure die casting, so then this is the software for them where they have a complete integration right from design till manufacturing. So whatever you have seen so far is all on the design front. Plus you also have electrode extraction. Once the electrode has been extracted, you can directly feed into the EDM machine so that it will read the XYZ coordinate system and then place the electrode on the job piece accurately. Going forward, we also have wire EDM software, which will take care of 2D axis profiling. Plus we also come across Visi Flow for plastic simulation. And here, whatever the options you have seen, it is much more faster and easier to create, to modify, or to work on the existing CAD data. We have a very dedicated commands and functionalities which are only requirement for tool makers. Hence the reason I would suggest you to, or I can recommend you to use an industry dedicated solution rather than using a generic CAD platform.
Thank you, Mr. Kiran, about the answer. So we go next to the third question from Mr. Reza Effendi. So Mr. Reza asks about, I take a look at the requirement for Visi in the Visi website, and for the operating system only support professional version. Is there any reason why only support professional version? That's the question.
Okay, thank you so much for Reza Effendi for asking this question. Why? Because most of the software has been tested with the same version. Because even in our office or in our development team, we use Windows Professional where we rigorously and extensively test the software with respect to the platform or Windows OS what we are using. So hence the reason this is a recommendation. So since most of the software functionalities like beta testing, alpha testing is all done in in Windows Professional OS, that's the recommendation goes with the customer as well. Suppose if you want to switch over to any other configuration or module from Windows OS, we can still perform it. But this is what the Professional OS version is what we have used and then tested the software.
Okay, thank you, Mr. Kiran, about the answer. So we go next to the fourth question. Is because there is a similar question from another about the minimum and recommended specification to running Visi software, as well as the license option to running Visi software. Is it only permanent or only subscription? And maybe you can also explain about the standalone or network license provided in the Visi. That's the question.
Okay, once again, I would like to thanks for asking this question. So to answer the first part, we have both a network as well as standalone license. Suppose if you are using, more than one license, and if you want to, if you have a design team where most of the engineers working on Visi license, you can go for network license, where the network license will be installed in one common location or a server, and all the client machines can access it through VPN or a LAN connection. And then we also have a recommended and minimum requirement, because sometimes I might not use the full capabilities of Visi software. So for example, I just use for opening the model, create some design or make some drawing and then use it. So for this case, you can still rely upon very minimal computer hardware. Suppose if you are using extensively all the modules like Visi Flow, Visi Mold, and simulation, analysis, everything, then the recommended graphics card or the CAD workstation is what we are going to use it.
Thank you, Mr. Kiran, for the answer. So we go next to the...
Sorry, Mr. Dwi, I think
yes.
I have missed one more. This is on a perpetual or subscription license.
Oh, yeah,
so
correct.
This license is a perpetual license.
Okay, thank you, Mr. Kiran. So
Yeah.
we can go to the next question. This question coming from Mr. Aib Supriyatna. So this question already answered in the Q&A chatting box, yeah. But we re-answer this question because maybe you guys not hear the answer. Does Visi mode can determine to split parting line of core and cavity without any draft angle automatically? So this is the question, Mr. Kiran.
Yes. Yes, it is possible to create a split of a given body even though it is not drafted. We can do that.
Okay, thank you. So coming to the next question from Mr. Dimas Panji. So Mr. Dimas Panji asks the question about does the software only can be used to create a plastic mold? Can we use to make tire mold? That's the question.
Okay, to answer this question, for designing, we can perform either for plastic or metal injection molding. But when it comes to a flow analysis, this can only be used for plastic material, not for metal material.
This is for tire industry, Mr. Kiran. Is it similar?
This is for tire industry, yeah?
Tire industry. The Mr. Dimas Panji coming from tire industry, I think.
Okay, you mean to say a rubber material?
Correct, rubber.
Yeah, for a designing aspect, we can still use it. But when it comes to a flow, so we need to look for what is that the material or a rubber they are using. If it is not available, you have to customize all the properties and then use it for flow. But I don't think so. This will be useful for on a simulation aspect, but for design, yes, they can use it. For a CAD function, they can still use Visi for tire or rubber material made mode also.
Ya, jadi gitu Pak Panji jawabannya. Kalau untuk desain aspek sih bisa ya. Kayak untuk gate-nya juga termasuk itu bisa. Cuman kalau untuk simulasi kita harus cek dulu materialnya karena untuk simulasi ini banyak pengaruh dari material juga properti materialnya seperti apa. Okay, so there is a question again from Novianto. Mr. Novianto asks about Mr. Novianto asking the question about how about the calculation, TCO calculation to handle maintenance in molding and tooling. I think do you get the point of the question, Mr. Kiran?
No, sorry, Mr. V, I didn't get that.
Okay, Mr. Bano, are you still there?
Yes, Mas Dwi.
maybe you can translate properly to Mr. Kiran about the question from Mr. Novianto Jaya regarding TCO calculation. Or maybe Mr. Novianto, you can put what is TCO?
Novianto. What in bahasa, Pak? Dwi.
Hitungan TCO-nya seperti apa jika kita menggunakan produk ini, terutama untuk mengatasi maintenance molding di tooling. Maybe you can put, mungkin Pak Novianto bisa kasih keterangan TCO itu kepanjangannya
TCO,
apa?
ya betul, TCO-nya betul.
So we can skip to the question ya. Maybe this is the last question ya.
Atau mungkin Pak Novianto ini sepertinya menanyakan mengenai hitungan shoot untuk injection molding ya. Bisa katakan tahan berapa lama untuk moldnya? Ya, mungkin bisa. Kalau Pak Novianto ya, kalau memang betul itu maksudnya bisa diinformasikan ke kami
betul
juga.
Betul itu Pak, mungkin bisa dibantu translate ke Pak Kiran.
So Mr. Kiran, maybe the question like this. So when we want to create design for mold, can we also calculate how long the mold will be extend ya? I mean until broken the mold. Can we do calculate for that?
Okay, I understand this question like this.
Thank you, Mr. Kiran.
Yeah, do you mean to say that the structural analysis or the structural strength of a mold can be analyzed?
Yes.
No, I think the life of the mold. Yeah.
I mean, no, we don't have that functionality. That comes under FEA or a structural part, and we do not have structural simulation of any material.
Okay.
What we consider here is a finite volume difference method, where we simulate the flow of a particle, of a plastic particle, but the simulation of any structural material, we don't do that.
Okay, but for the mold material, we can put the library.
Yes, you can add a material to the mold library.
Okay, thank you for your answer. Oke, Pak Novianto, jadi mungkin untuk jawabannya tadi kurang lebihnya bahwa untuk perhitungannya, kalau memang betul itu yang dimaksud, TCO-nya ini, kita tidak bisa menghitung sampai dengan ketahanan moldnya ya, tapi mungkin untuk hanya materialnya saja digunakan itu kita bisa asumsikan di library yang kita ada, seperti itu.
Oke, Pak Bambang. Halo Pak Bambang.
Ya, Mas Dwi.
Ini Mr. Kiran and Mr. Ahmed, maybe this is the last question ya, coming from Mr. Andi Hajah Perwira. Pak Bambang mungkin bisa bantu translate juga nih karena
Andi Hajah, wait.
Yang karena software ini membantu dalam proses manufaktur molding, apakah simulasi mold proses menggunakan software akan sama dengan hasil cetak dari mesin yang sudah diinput data dari simulasi? Maksudnya seberapa presisi, seberapa akurat data hasil simulasi dengan aktual pemodelannya, mungkin seperti itu kali.
Oke. Pengalaman saya perlu geometri di dimensi punch and dice. Kayaknya ini lebih ngebahasnya bukan ke plastik injection, Mas. Ini lebih ke die casting ya, untuk stamping. Pengalaman saya perlu dilakukan optimalisasi geometri dan dimensi punch dice dengan proses molding untuk menghasilkan produksi yang diinginkan. Pak Andi mungkin bisa lebih spesifik ini untuk aplikasinya rencananya untuk di die casting, stamping atau plastik injection ya?
Ini
kalau dari informasi,
apakah hasil simulasi mold proses menggunakan software akan sama dengan hasil cetak dari mesin yang sudah diinput dari data simulasi? Karena pengalaman dia tetap harus di-repair moldingnya, mungkin seperti itu.
Iya, itu maksudnya dimensi punch-nya itu takutnya punch and die-nya takutnya masih salah ke die casting. Coba untuk lebih, takutnya salah ini persepsi Mas Dwi.
Ya.
Pak Andi, mungkin kalau bisa dengar suara saya, kalau untuk lebih detailnya ini lebih ke plastic injection atau ke die casting ya? So maybe Mr. Kiran, for plastic injection, normally we have to compare with the result with the real case ya. So do you have like a slide to share to us about your success story about the plastic injection to compare with the real case?
Like what exactly you want me to share?
I mean like this. So for example, like ROI to when we use Visi mold, we can reduce the trial and error or something like that. Because normally
Okay.
to do simulation, normally we have to waste a cost for material, and also sometimes we have to repair the mold, right?
Yes.
So if we have VC, maybe we can help them to reduce that thing.
Yes, we have our customer, like as I mentioned, Cross and Engineering, where already they are using our, Visi license. Okay, so they are now using completely for 3D tool design, plastic simulation, everything. So if you want, I can, show that how they have been useful this software and then benefited out of it.
Yes, thank you, Mister. If you have, you can share that presentation.
Yes, probably I will be just, if you want, shall I share my screen or shall I put it on to you separately over an email?
Would you like to share your screen, Mr. Kiran?
It's actually a testimonial. I have got a PDF document shared by our customer where they have talked about how Visi flow license, how Visi mold was helpful for them in order to make easy adjustments, and then how they have improved their turnaround with the mold inserts, everything, reduced error and increased performance of the final mold.
Okay, so if you would like to share the screen, I will make you a host, yeah, Mr. Kiran.
Yeah, that would be better.
Okay. So you can share the screen now.
Okay. I hope you all see my screen now.
Yes.
Okay. So this is what the customer from Crossan Engineering, they talked about it. Okay, the company name called Crossan Engineering. They are injection molding specialists. This is their website. You can also refer their website. They provide a service to various industry vertical, right from automotive, aerospace, medical, construction, household, and material handling. So they have used complete Visi license. Hope you can see that. Yeah, there you go. You see, the other side to the family run operation press tools, they have 13 presses in place, ranging from 50 to 500 tons, and all they have used using Visi itself and manufactured in-house. So they have reduced error and increased performance of the final mold. What VisiFlow has done, preventive analysis. Software optimizes the tool design and molding parameters by detecting a wide range of potential manufacturing issues. So any adjustments, any modification, they can do it quickly and easily with our flow license, VisiMold. So this is what the managing director has talked about it. Their superior technical expertise, ability to deliver within the rigid lead time, and their service have all helped Blanc become a market leader in the manufacturer and supply of innovative and award-winning window blinds. So that's how they are using it. You see, they have used Visi CAD module for several years, but have only recently installed VisiFlow, which is now playing an increasingly important part in their process. So this is what one more question was asked, which is on positioning or optimizing the gate size, position and location along with the runner. You can see that he has stated the same thing. The preventive analysis software optimizes the tool design and molding parameters by detecting a wide range of potential manufacturing issues such as warpage, well lines, air traps, filling issues, and hotspots, while determining the optimum gate size and position along with runners. So that gives the total confidence for the parts that are achieving using VisiFlow license. So here it has got a detailed story, what they have using and how it is built. It has been benefited for them. So this you can make use of it. I've got many more case studies like that. So there are so many customers who are using our product across the globe. So I think, yeah. This is one more customer on using Visi Electrode. You see, Visi Electrode has reduced design time by 80%, with each electrode now taking less than 10 minutes to produce. So this is the benefit what they have stated. They are using Sodic AG60L6 station tool chain spark eroder for maximizing the lightout usage. So, I mean, I have a lot of customers where they have shared their success story with us. I hope this is helpful.
Oke, thank you Mr. Kiran for your answer.
Thank you.
Oke,
Mr.
jadi
Kiran.
teman-teman, ya teman-teman di sini mungkin sudah tidak diragukan lagi untuk capable dari software Visi sendiri di sini sudah sangat powerful ya untuk menjawab pertanyaan-pertanyaan yang Bapak ajukan seperti itu.
Iya, betul. Oke, Mr. Kiran, can you make me a host again? Dwi. You can click Dwi more and make a host. Because I cannot share the screen and watching the poll.
Oh, okay. I'm so sorry. Sorry.
Mr. Kiran,
Mas,
I think
yes.
I want to have one question to answer. Yeah, sorry Mas Di. To try to answer the customer because I just don't want the audience confused about the flow simulation in here. So for VC only can do simulation for plastic injection or can do also plastic casting simulation?
No, only plastic, no casting.
Only plastic, oke.
Yes,
jadi
only plastic.
Bisa lihat, jadi untuk yang kita bisa simulasikan hanya untuk plastic injection. Tapi kalau untuk mendesain, kita bisa mendesain untuk dies, untuk yang lain juga seperti itu bisa. Seperti tadi yang mungkin tire itu bisa, tapi untuk capable untuk flow simulasinya kita hanya untuk plastik.
Oh iya, mungkin juga yang belum disinggung ini, Visi juga sebenarnya punya capability untuk reverse engineering ya.
Yes, ya.
Kayaknya makin kesini makin menarik dan
makin seru.
Banyak terus ya. Tapi kita karena terbatas oleh waktu, mungkin nanti pertanyaan-pertanyaan yang nggak terjawab bisa kita jawab di kesempatan yang lain ya. Mungkin kita mau launching poll juga nih. Pak Bang bisa launching poll di situ?
Oh boleh saya launching lagi.
Kayaknya yang poin terakhir ya. Kan itu ada polling
launching berarti ya?
Oh, saya udah jadi host nih. Udah bisa launching polling. Saya yang launching deh.
Oke.
Ambil launching yang terakhir. Jadi Bapak-Bapak, ini kita sudah masuk ke sesi terakhir. Nanti saya akan bacakan siapa yang berhak mendapatkan hadiah Rp100.000 ya. Tapi sebelum itu mohon dibantu untuk isi pollingnya nih. Kita ada polling terakhir. Ada 2 pertanyaan doang. Silakan diisi pollingnya. Ya, silakan. Pollingnya sudah jalan. Silakan diisi pollingnya. Kita akan kasih waktu sekitar 1 menit saja untuk isi polling ini. Jadi pollingnya adalah yang pertama, apakah Anda ingin kami presentasi di tempat atau di perusahaan Bapak untuk menjelaskan produk Visi CAD CAM lebih detail? Silakan buat Bapak-Bapak dan Ibu-Ibu yang merasa perlu penjelasan lebih lanjut, silakan isi pertanyaan dari polling ini. Nanti kita akan coba follow up jika memang Bapak perlu penjelasan lebih lanjut ya. Yang kedua, apakah Anda mau mencoba trial Visi CAD CAM? Ya kalau memang Bapak-Bapak merasa perlu untuk mencoba software ini karena dilihat tadi softwarenya bisa membantu pekerjaan Bapak, terutama mungkin di plastik flow-nya untuk analisa supaya nanti buat mau desainnya juga lebih efisien, lebih produktif. Silakan diisi pertanyaan di polling ini. Oke, kita masih ada waktu sekitar 15 detik lagi untuk diisi. Jadi buat Bapak-Bapak dan Ibu-Ibu yang belum isi, mohon bantuannya untuk diisi pollingnya.
Mungkin Mas Dwi saya mau sedikit tambahkan. Jadi untuk teman-teman di sini tadi betul sudah terjawab untuk yang kita bisa lakukan simulasi hanya untuk plastic injection. Tapi tadi kita tidak menutup kemungkinan untuk mendesain moldnya yang sangat powerful di kita tadi. Mas Dwi sempat sounding juga. Mungkin kita bisa tunjukkan bahwa kita pembuatan parting line-nya sangat mudah, Pak. Karena setahu saya untuk pembuatan parting line di plastic injection ataupun di casting yang lain pun itu sangat sulit. Biasanya lebih banyak sangat menggunakan surfacing. Nah, di Visi ini ada automatic surfacing-nya seperti itu untuk pembuatan parting line.
Baik. Kayaknya udah cukup nih kita launching pollingnya. Jadi saya ucapkan terima kasih kepada Bapak-Bapak yang sudah isi pollingnya. kita akan masuk ke sesi berikutnya. Kita bacakan siapa yang berhak mendapatkan hadiah sebesar 100.000 ya Pak Bambang. Mungkin Pak Bambang
Iya.
mau bantu untuk ini, untuk seleksi siapa?
Di sini saya pegang 3 nama. Totalnya ada berapa Mas Dwi?
Ada 2 orang aja Pak yang dipilih.
Oh, 2 orang. Oke.
Satunya boleh Pak dapat kaos, nanti kita ada kaos kan masih?
Itu maksudnya. Boleh.
Pak,
Boleh.
silakan.
Oke, saya mungkin bisa sebutkan satu nama dari yang sangat aktif di sini, mungkin dengan Pak Ang Sudiang ya, yang saya tadi sudah menanyakan masalah capable dari software Visi sendiri. Jadi selamat untuk pertanyaannya Pak Ang Sudiang mendapatkan 1 voucher dari pihak kami. Oke, yang keduanya silakan Mas Dwi.
Oke, sebentar tadi siapa ya namanya yang nanya tentang tire itu ya Pak, tire mold.
Gajah Tunggal itu, dari orang Gajah Tunggal.
Siapa tadi ya namanya di sini?
Bentar. Orang Gajah Tunggal. Tadi dia tulis namanya sih Gajah Tunggal. Sebentar. Saya juga nggak note di situ.
Oh, Dimas Panji. Ya, selamat kepada Mas Dimas Panji. So, Dimas Panji sama siapa Pak Bambang? Satu tadi? Pak Ang Sudiang.
Pak Ang. Ya, Pak Ang Sudiang, betul.
Oh, satu lagi yang dapat kaos siapa Pak?
Pak Dimas Panji, Pak Ang Sudiang, sama mungkin yang tadi sudah sempat menanyakan juga dengan di sini saya sudah note untuk Pak Reja Effendi untuk 1 kaos ya.
Ya, kita ucapkan selamat kepada para pemenang. Nanti tim dari kami akan coba menghubungi lebih lanjut untuk mengirimkan hadiahnya. Oke, we already coming to the end of the session. We want to say thank you for all participants here, and we would like to say thank you also to the speaker today, to Mr. Amit and Mr. Kiran for your...
Thank you, Mr. Amit. Thank you, Mr. Kiran.
Thank you. Thank you
for
having
your time.
us.
Yeah.
And thank you to all the customers also who take their time to join this Visi webinar. Thank you. Terima kasih.
Ya, terima kasih, Mr.
Welcome, Mr. Amit. Ya, terima kasih ya kepada bapak-bapak dan ibu-ibu yang sudah hadir di webinar ini. Jadi, bisa lihat ini ya PPT saya. Jadi di minggu depan kita ada webinar juga, bapak-bapak, ibu-ibu. Jadi kalau nanti mungkin berminat untuk ikut webinarnya, silakan hubungi kami atau nanti juga tim kami akan kirim email untuk webinar selanjutnya pada tanggal 24 Juni mengenai walk and see robo. Jadi ini adalah salah satu solusi juga dari Hexagon untuk bikin CAM toolpad-nya termasuk robot simulation-nya. Ya, kalau mungkin nanti di tempat bapak-bapak dan ibu-ibu ada proses CAM, manufaktur proses, tapi menggunakan robot, itu nanti kita bisa bantu untuk programming CAM-nya dan juga simulasi robotnya. Nah, ini kita akan bahas topik webinar ini di hari Rabu ya Pak Bambang ya, tanggal 24 Juni di jam yang sama. Dan juga kita bulan Juli ada webinar yang cukup menarik. Ini ada webinar NC Simul, ini adalah CNC mesin simulation untuk mensimulasikan G-code yang bapak-bapak sudah buat di software CAM. Termasuk di situ kita bisa optimalisasi iCAD dari G-code yang bapak-bapak buat. Dan juga nanti ada webinar untuk radan Pak. Misalnya Bapak di tempatnya ada sheet metal proses seperti pancing, profiling, nesting, dan seterusnya. Kita akan bahas itu di radan ya, webinar radan pada tanggal 1 Juli. Di jam yang sama ya, nanti tim kami juga akan coba hubungi bapak-bapak via email. Oke, terima kasih sekali lagi kepada bapak-bapak dan ibu-ibu. Jangan lupa untuk subscribe channel ECE Spesifik di ACA 3D ya. Kurang lebihnya kami ingin mengucapkan permohonan maaf dan juga terima kasih sekali lagi sudah hadir di webinar kali ini. Sampai jumpa di webinar selanjutnya. Kami ucapkan wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Mas Dwi.
Terima kasih Pak Bambang, terima kasih Pak Kiran dan Pak Amit. Thank you Mr. Amit and Mr. Kiran.
Terima kasih. Terima kasih. Thank you.